Welcome to Manufacturing Tech Australia with Shane Williams and Paul Mason.
G'day folks, how you going? Welcome to what is going to be a live recording of Manufacturing Tech Australia podcast. So have your questions ready because you're going to be on the show.
He will be joined by Ben McCulloch, Category Manager for Sustainability at Martogg Company, Edward Vawdrey, CEO of Popit Recycling, who is pioneering a low-cost recycling solution, and Taylor Quinn, National Fleet Logistics and Sustainability Manager at Procal Dairies. They'll be discussing how they plan to make recycled content cheaper than virgin, making circular packaging a commercial reality. Please welcome them all to the stage.
Ben, you haven't even left the stage yet. You were just here, so I might just duck straight to you. Maybe set the scene for us. Like, what is the scene at the moment in terms of the ability to source, leverage recycled products in the dairy industry?
Look, they're available. I guess the bottom line is as I mentioned in the previous session, is that they're more expensive than virgin polymer. So the adoption of recycled content back into milk bottles is few and far at present. And that sort of, that is one of the key reasons that we see, very little use of it back into product.
So why has the recycled product stayed at arm's length? Why wasn't it more readily adopted?
I think there's a whole caveat of other reasons outside of price, but milk bottles being a bit of a loss leader type product in a way. Taylor, you can talk to this point as well. There is, through conventional mechanical recycling, typically a very big premium associated with recycled content or recycled HDPE food grade compared to virgin polymer. That's not just Australia-wide. That is global for all essentially food grade recycled polymers.
And so, in essence, the reason that there's not higher adoption is largely that the processing to enable it is cost prohibitive. Is that fair?
Essentially, yes.
Yeah.
I'd say that is the core issue at play. Yeah.
So, Taylor, I can see you nodding your head there as the gentleman who's got to produce and then make use of the product. Tell us a little bit more about what that means for you.
For us, obviously, the price has got to be competitive. We're playing in a space where, we're selling milk for $3 a bottle, and the polymers. I mean, it's just a very expensive cost. So, what started for us is a way to get our crates back, and now we're turning it into a way to put it back into our own product, which is something pretty unique. So.
There's been a lot of noise lately around some geopolitical issues which have pushed up the cost, or at least have created a bit of noise around the input costs for creating those sorts of products. Has that had any material impact on the cost equation?
It's starting to make it more affordable, definitely, but it will never obviously replace virgin. Yeah. Well, we hope it will eventually, but it won't replace that virgin cost just yet. But as of recently, it's definitely been let's move this timeline up the road a bit.
Yeah, I think so. Just on that, the two big reasons that mechanically recycled polymers, food grade in particular, cost more than virgin. One, it's scale. So if you compare, say virgin polymer plants around the world, it's not surprising these days to see plants that are doing 1 million tonnes per annum. On the flip side, some of the bigger recycled polymer plants are 50,000 tonnes per annum. So scale's the first thing. The second thing is that the process involved in converting a post-consumer milk bottle all the way through to a food-grade recycled polymer is quite extensive. There's quite a few processes. So just talking through that, obviously the consumer's hopefully putting their milk bottle in their recycling bin. That will be collected. It will go to a material recovery facility where it will be sorted into a high quality bale of essentially milk bottles. It will then have to go through to a wash plant where it will be sorted, washed, granulated into a flake form, additional sorting to get it to a high purity, and then it's going to a very highly sophisticated decontamination and extrusion plant. So just in that, there's a lot of logistics, there's a lot of processes, high cost processes involved. So, you know, my feel from within the plastics industry certainly is that these, you know, premium food grade recycled polymers will always trade at a premium to virgin polymers. Now, notwithstanding the recent events through the Middle East conflict, we obviously saw virgin polymer pricing lift quite significantly. And whilst that will stay somewhat elevated, you know, I think if you look at the next 5 years, you will see that trend continue of these you know, premium food grade recycled polymers remaining at that premium.
So then it seems to me that the industry's response to more adoption of recycling is largely just to push up the cost of virgin product to make it more cost competitive, a little bit like a trade barrier in another industry. I guess that's some of the promise or the premise behind Popit. So maybe, Ed, maybe talk us a little bit about what you're doing differently and how you're tackling the problem from a different angle.
Yeah, so just to pick up on the points Ben was making, so you know, the premise behind Popit Recycling was to address the cost premium of recycled plastic. So when we go and talk to milk processors like Procal, there are a couple of barriers in the way around adoption of recycled plastic, and we have to say that as it stands today, there's one company out there with some recycled content in their bottle, so the rest of the milk bottles in Australia today are at 0%, so there is a real challenge. And the two things that we hear when we have these conversations are cost, and they are also cleanliness around the feedstock material. So when we sort of looked at the process of producing recycled plastics in Australia, what we could see was there's a huge amount of embedded costs in the collection recovery of the feedstock material. So recycled HDPE for milk bottles, it's produced from post-consumer milk bottles. That's the only container that can be used in the process. So, and it's an expensive process, even though people are used to recycling bottles at home and putting them in their recycling bin. By the time they get through collection, into a recovery centre, through the recovery centre and out into a bale of milk bottle, we're talking $600 to $800 a tonne. So that cost is embedded in the cost of the finished product. And that's where we decided to intervene and try and make some cost savings in the process. And that was the starting point for Popit.
So maybe, why don't we walk through the process end to end? And obviously, you might as well kick the conversation off. For the folks who haven't, we kind of talked about it at a high level, but let's get into the specifics. Taylor's Group's just send a bottle out from the factory with potentially it's virgin plastic. What happens next?
Yeah, so with Popit, we've developed some equipment that I'll talk about in a minute, but what we are targeting is milk bottles that are currently being sold into what we call food service. So milk companies like Procal, they're filling bottles, they're putting those bottles into crates, and they will operate a network of trucks to deliver those bottles out to restaurants, cafés, institutions, and those sorts of business B2B customers. So what we're targeting is the collection of those bottles to come back to Procal's site. So when a truck delivers milk to a restaurant, for example, they collect the empty crates from the day before. What we're now asking those restaurants to do is to put the empty bottle back into the crate so that it can be collected by Procal's trucks and brought back to site. The benefit for the restaurant in doing that is they don't need to recycle the bottle themselves. So, for a commercial property, there's a cost in having a recycling bin collected, so there's a cost saving for the site. Once the bottle is back at Procal, and that logistics process is happening with trucks returning to base, so it's a sunk cost, we're not adding any additional logistics costs, we essentially end up with a fairly clean stream of post-consumer bottles arriving at Procal's site, right? So that in itself saves a huge amount of that embedded cost I talked about a moment ago in terms of collecting and recovering bottles. And then what we've done is we've developed some equipment for Procal's site so that we can do a substantial part of that recovery and recycling process there. Again, eliminating more logistic steps before the material is finally shipped to our partners at Martogg to finish it off. In terms of the equipment, just very quickly, we can get into the detail, but just we've got 3 pieces of equipment in our plant. So it's essentially a small modular hot wash plant is what we call it. There is a recovery module. So when bottles come back to the site in crates, that module attaches to existing crate handling infrastructure at the milk processing site, It empties bottles out of crates, it scans those bottles, and it removes any contaminant from the process before feeding the bottles into the next stage of our process. So that's our second module. It's our flaking module. Once the bottles are inside there, we're giving them a rinse. We're cutting them into what we call flake, which is like confetti. And then we're loading that into a bulk bag. And those bulk bags are then transported to our final piece of the plant, which is located at Martogg site. It's our hot wash module. It takes those rinsed pieces of flake, it takes them through a hot caustic wash process, which is required for us to go back into food contact applications. So we go through a hot wash tank with caustic in there to give it a clean. We remove all the glue, we remove all of the labels. We take that flake through a drying process, and then we finally take it through a flake sorting process where we sort it by colour and polymer. And what we end up with is 2 grades of flake. There's an A grade flake, which is our washed natural flake, which will eventually end up back into bottles. And we have our B grade flake, which is all the closures and labels and other bits and pieces that can be used into other applications.
Yeah, right. So, Ben, I'm going to come to your stage of the process in a second, but I'd just like to draw on something you said earlier, which I think is really important here, is that in a traditional process, that bottle has then left the cafe, it's gone into general recycling, it's had to be resorted, and all that is additional steps and costs and whatever, which largely would make the whole, using it as an input stock, cost prohibitive. That's broken that process down, taken out a bunch of steps, and using existing logistics is what is going to make this cost effective, right?
Yeah, I guess you're using that backloading of crates that are going back to the dairies anyway, because they don't want to lose. Historically there's been significant loss of crates at dairies, significant costs. So they're simply using that existing supply chain channel to take the bottles back that are effectively coming in at no cost. It was a little bit silly because I've been sitting here the last hour saying that through conventional mechanical recycling, you're never going to see food grade recycled content below virgin, but through this process and the various process, it's a very real scenario effectively for the dairies. And the only thing I would add in there as well is that it's so rare to see situations of collaboration where you've got product reuse in the form of crates. You've got low cost food grade recycled content, but you've also got operational site efficiencies at Procal. So it is that genuine, win-win-win. There's benefit to each of the parties involved in this process. But, where we come into it, where we specialise in actually recycling, flake into polymer, we've got the technology, in this case, it's a REMA refresher technology that takes a hot washed flake. So in this case, a milk bottle that's been through the process that Ed has spoken about. And it decontaminates that flake, converting it into a food grade, FDA compliant food grade recycled polymer, which is fit for purpose back into milk bottles and a very broad range of other HDPE FMCG products.
So obviously for this use case, being food grade is ultimately important. What's unique about what you guys have added to that process that means that it is potentially usable for food grade products?
Yeah, so without our technology, it would just be a hot wash flake. It's this sort of technology. It's not as if there's 10 different businesses in Australia that has it. There is a pretty high level of cost associated with that. So effectively, the part that we play in it is decontaminating and extruding that flake through a molten form into a plastic pallet, which will then go back to the likes of Procal and Taylor here, where they will use it back into their bottles at a percentage.
So you've had the first machine in with Taylor and the guys at Procal for a while. Why Procal, and why have you, because you talked earlier about having to replace that machine at some point. I'm guessing you've been through several iterations of your process. Maybe talk to us a little bit about, what did each phase of that pilot teach you that got you to where you are now?
Why Procal? Because Taylor was very interested in looking at this particular problem. So how could they make use of these post-consumer bottles? how could they live up to the commitments made to go to recycled content in bottles with the commercial challenges that were there. And Procal have been fantastic in that they've been prepared to work with us and be the pioneers of the process. So without them, we would have nowhere to develop and test, so it's been fantastic. In terms of our first piece of equipment, we deployed that in August last year. So we deployed sort of 1.5 of the 3 pieces. We've been running that in production since, so it's still in production. Like with every pilot and prototype, we learned lots about what was good and what was not good. In particular, we're dealing with a very dirty product at that stage of the process. So our main technical challenges have all been around handling a very dirty product inside of our machine. So our machine, I wish I had a photo here, but I don't. But it's fully enclosed. It's roughly the size of a 20-foot shipping container. And it's an automated process. So once the bottles go in, they just flow through the process and come out the other end. There's no operator intervention inside the unit. Our main challenge and our main learning has been at the front end of that process, handling firstly bottles and then flake when it's still in a very dirty format has been difficult. We've got lots of feedback from Procal and the people involved in the equipment around keeping it clean and maintaining cleanliness on the site and all that sort of stuff. So there's been that valuable information. Phase 2 of that unit is actually being commissioned at Procal this Friday. It was meant to be the week previous, so we would have had some photos, but we don't, unfortunately. Very excited to sort of go to that next stage and that next generation of the equipment.
So Taylor, I might jump to you now, mate. We've sort of talked about the economics of this, right? But it really, I imagine, for a business like yours, this only stacks up if it's cost-effective economically. But there's also the additional benefits, I imagine, of a business looking into sustainability. I'd love to hear from you about what were the drivers for you, what have you seen through it, and what do you see next in terms of the value to a business like yours for adopting this sort of technology?
Sorry. Well, basically, as I said earlier, it started from, we've been returning or collecting our milk bottles from our customers for the best part of 10 years now. But it started off as a way to get crates back at $4 a unit that we buy in the vicinity of $700,000, $800,000 a year on. We needed a way to get that back. So what originally stemmed from a very inefficient process, we just basically emptied it into major compactors and transported it over to the western suburbs. Maybe sort of work out that, we've got to do something differently. And that's where, through, the power of the internet, found Martogg and Popit, and basically the whole thing took off from there, effectively, being able to offer a recycled product in a food grade container other than PET, potentially being able to be the first to do that is something incredible. I never actually thought that we'd get to that point. I just wanted to do it more efficiently, to be honest.
Yeah, no, fair enough. And so I guess it's all about, what's in it for you and what's in it for the business, and that makes total sense. We're talking about milk bottles. Obviously, Procal produces more than just milk.
Yep.
Are you guys collectively seeing future uses for other types of food-grade plastics for the products that you guys produce?
Yeah, so we produce, obviously milk is the primary, but yogurts and things like that as well. We do recycle as much as we possibly can, and with APCO we have to have certain percentages of packaging that we use with recycled content in it. There's never been something about the milk bottle itself, so that was what this sort of helps in that instance. But yeah, there's just such a push from our customer base to have recycled in as much things as possible that you've got to get involved. So being a pioneer is definitely a good selling point.
100%.
Shane, just the other thing that I would mention here as well. So, obviously there's quite a few dairy businesses that are set up quite similarly to Procal that are ideally trying to return as many crates as possible, so have a similar setup with materials coming back on site. And one thing it does do is that it keeps a valuable recyclable material in Australia, key buzzword, circular economy. Some of these other players were collecting and baling material, but having that material sent offshore. Yeah. So I think it's quite valuable to, obviously understand that it's staying in Australia for use in Australia.
So I'm guessing, Ben, this is probably a question for you. When we're thinking about recycled product, this isn't going to be 100% recycled plastic that goes into these bottles. What have you experimented with in terms of mix and what works, what doesn't, and if you can share, what's the sweet spot and where do you see it going?
Yeah, it depends what product you're talking about. I mean, milk products, as we know, very highly price sensitive. If you compare that to a cosmetic product in HDPE, significantly higher value, typically thicker wall section. So it's not uncommon to see recycled HDPE at 100% into FMCG products. There are some considerations in there with respect to material performance into certain applications, chemicals and so forth. But if we look at milk bottles, typically the work we've been doing are around that 30 to 50% sweet spot from a commercial perspective. And again, that fitness for purpose back into the application. Could it go to 100%? Yes, but I don't think we'll see that happen. I don't think it needs to happen. There's enough of it to go back in at a percentage to cover off a lot of products within the industry. And I think what we will see if government does mandate recycled content in Australia is those sort of not limits, but percentages around that 30% mark.
Yeah. That makes sense. Might come back to you, Ed. We've been closing the loop on what's next. So we've proved this case out. You've got your first site live. I can't imagine the next step for the growth or the trajectory for what you guys are doing is to just pump out 1 million of these machines and put them on every shop corner. So what's next?
Yeah, so our immediate goal is to get the plant bedded down in its current form, operating, but crucially proving the economics. So we've talked about making recycled HDPE at or below the cost of virgin. That's always been our goal. So we want to get to that point fairly quickly that we can get recycled content back into Procal's bottles, assess the total commercial impact of that and prove that what we're doing is on the right track. Beyond that, there's another 4 milk processors who've all made commitments to go with a Popit system once we're bedded in at Procal. So there's the next 4 units. Each time we do this, we'll get an opportunity to improve the technology and the process. Beyond that, I would love to see this become kind of the standard in dairy. Kind of when I look around the industry, the economics of this makes sense when you've got a couple of 100 tonnes of HDPE bottles recoverable per site per year. So when I look at that, I think there's probably in the range of 15 to 20 sites in Australia, potentially, is the complete market for what we're doing here. Beyond getting it right, proving the economics, the next 4 sites, I'd love to see, 15 or 20 Popits around Australia at some point.
And when you're pumping it, 20 Popits around the country, what sort of volume of recycling are we talking about?
Well, it will depend, but each of those sites will be in the range of, say, 200 to 700 tonnes a year. So, yeah.
So not an insignificant amount. And obviously, from a circular economy and sustainability perspective, a massive achievement. Congratulations.
Thank you. Yeah, we're pretty proud of it. Yep.
Taylor, how do you feel about the fact that potentially your competitors might be able to pick up on your good work and goodwill, my friend?
Listen, there's been a fair few conferences we've been to, and we've been talking about the project with my competitors, and we're delaying things. We're taking our sweet time with certain contracts. There's certain little problems that just won't go away, so we'll just extend that as far as we can. No, at least we're hoping. I think the next one was supposed to be in another state that we don't compete with, so I can't complain too much about that. But listen, it is what it is, but we'll still be the first, and I'm hoping that everything that Popit produces will always have Procal next to it, so that's all right.
Thanks for playing along. That was good fun. Ed, a question that's just without notice has just come to mind, which is, it's great that we've come up with this, way to recycle the plastics products. What about as you create new innovations and improve your solution? is it modular enough that you can retrofit the existing ones, or is it you've got to recycle that machine and bring in a new one? So, for example, you've come up with a version 3 that is learned from the next 3 dairies that you've worked with. Do the machines, are they retrofittable so you can?
Yeah, absolutely. So, that's the beauty of having this modular design, fully enclosed. When we make enhancements or changes, they can slot in easily to all the machines that we operate. So that's absolutely the idea.
Amazing. All right, so we might jump to the audience. Has anyone got a question that you'd like to ask anyone on the panel?
Yeah, I really like that question about being, can you upgrade the system that you were just talking about, Shane? I guess in terms of AI and that kind of, learning intelligence and that kind of thing, I know that you're sort of already scanning using some cameras and stuff like that to identify, what's your plan there in terms of intelligence for sorting and cleaning and that side of things?
Yes, that's a really good question. So probably something we didn't really talk about was the reason we've had to develop Popit is because there isn't such a thing today, right? So recycling equipment is designed for very large plants, much higher volumes, significant capital really to buy bits of equipment. For all of this to work and make economic sense, it needs to be small enough to fit on Procal's site, and it needs to be cheap enough to make sense for 200 tonnes plus per year. So it was always our goal to make a piece of equipment that was at least 10 times smaller in footprint and 10 times cheaper in cost than buying equivalent equipment for a large-scale recycling plant. And to do that, we've had to be a bit creative around how the processes of recovery and recycling, they don't substantially change, but we've had to be creative around how we build the technology around those processes, both in terms of its size but also its cost. So we have utilised AI vision both at the front end and the back end of our process. So unlike a typical resource recovery centre or even wash plant, the likes of Circular AU at Martogg, we have a fairly consistent input of material. We've got 99% milk bottles. So when we do our recovery process, we're looking to remove a very relatively small amount of contamination. And that means we get a really clean process, but it also means we've got an AI that doesn't have to look for everything, so we can develop quite a low-cost and agile version of what you might see at a large-scale plant. And at the back end of that process, the same thing. Because we are very good at detecting contamination at the front end, we rarely see any at the back end. That means we can run a fairly low-cost, low-speed process, and it's very capable. So, yeah, the technologies like AI, we are using in similar but also slightly different ways to what you'd see in a traditional plant.
Anyone else? Yeah.
Why did we move from glass to plastics? Is it that much more expensive for glass?
I can probably touch on that a little bit. It's just a more, in a lot of instances, a more fit for purpose packaging medium. It's lightweight. It serves the same process. It's a tougher material. So, I mean, logistically, it's easier to move. It's cheaper. There's a whole number of different points to it. But you still, I mean, obviously, you still see glass in the market into certain products and doing certain things that plastic can't do. But there's a whole range of reasons as to why we've gone to, say, HDPE for a milk bottle in this case.
All right, gents, my few final thoughts. I think it's a really interesting demonstration of, multiple innovative companies coming together to solve a real problem, prove out a use case. I think a lot of what sort of, Paul and I, when we're doing our consulting work, see is that a lot of organisations don't collaborate. There's a lot of, I don't want to talk to these guys because they might steal my IP. And yet, when we do work together, there's a really clear demonstration of how each can bring their strength to the table to demonstrate and prove out a use case which is likely largely globally scalable, right? And really solving a genuine sustainability problem. Might be niche, but regardless, amazing. So well done, gents. Thank you also for sharing your experience, Taylor. I mean, it's not every day that someone will get up there and explain what's happening behind the scenes in their business. So thank you, and thanks everyone in the audience for joining us for the show. Thanks very much.
Thanks for tuning in to Manufacturing Tech Australia with Shane and Paul, recorded on the traditional lands of the Bunurong and Wurundjeri people. For more information, jump on the manufacturingtech.au website. Remember to hit the follow button to join us again next time as we continue to explore the intersection of manufacturing and technology.